Chapter 6 is getting into ratios and proportions and percents. So we're going to start learning about things that are very applicable, like sales tax or discounts and stuff like that. And we'll be able to use our calculator from here on out. But before we get there, we got to just make sure we understand the whole idea of ratios and what stuff like that. So ratios is a fractional notation where when you read it, you put the top number on, or the first number on top and the bottom number on the bottom. So if we want to know what the ratio of 20 to 30 is, what we're going to do is we're going to start over here and write 20 to 30. So that would be a ratio, but MyMathLab wouldn't accept it because it's not in lowest terms, all right? So if you have a graphing calculator, or even I think a scientific one might work, I'm going to show you how we do this on our graphing calculator, okay? It's one of my favorite buttons. You know you're a math teacher when you have a favorite button on your calculator. So go ahead and type 20 divided by 30 like that. If you have a graphing calculator, then hit this math button right here. It's the third one from the top. And fractions, the very first thing highlighted, if you hit enter twice, it takes any fraction and reduces it to 2/3, okay? Those that don't have a graphing calculator on your cell phone, we would just have to break it down like normal. So what multiplies to be 20, 2, and 10, but how does 20 break down? 2 and 5. So either way you do it, and then this is 3 times 10, right? So we can still do it the old-fashioned way. I'm just telling you we don't have to anymore because we have that graphing calculator. So the 2's would cross out, the 5's would cancel out. So what is the ratio really, 20 to 30? 2 to 3, okay? So maybe you have 20 parents and 30 kids. The ratio is for every 2 parents, there's 3 kids. Like we can kind of break it down smaller. So 16 to 10, it's the same idea, guys. If you have a graphing calculator, go ahead and put 16 divided by 10 in your calculator and hit MathFrac, and you'll get a reduced fraction of 8/5. Those that don't have it, we can break 16 down like normal. What is 16? 4 times 4, but each of those 4 split to 2 2's. So really this is 2 times 2 times 2 times 2 over 2 times 5, right? So one set of 2's is canceled, but what does that leave on top? 2 times 2, which is 4. 4 times 2 is 8. Those that have your graphing calculator, did you get 8/5? Okay. $30 to $65. You can put the unit, but since the units have to match, they're going to cancel out. If they don't match, they stay, like miles per hour or whatever it may be, okay? So from here on out, I'm just going to kind of jump to the right answer because we're breaking away from fractions, you know, so we should be able to put this in our graphing calculator. So if you do 30 divided by 65 in your graphing calculator and you hit MathFrac, you'll get 6/13. And the units cancel out too, all right? Those that are doing it by hand, you would break 30 down by 3 times 10, so 3 times 2 times 5. Or again, play around with your calculator to get the common things. Last one, 1.5 to 10. Put it in your calculator, 1.5 divided by 10, hit MathFrac, you'll get 3/20, okay? Those that are doing it by hand, we can't break down decimals, but what we can do is we can scoot the decimal over one spot on top and bottom. So this is really the same thing as 15/100. And then you could break that down, 3 times 5, and okay? So anytime you have a decimal, kind of like when we do division, move it over how many spots you need to make it not a decimal, okay? So 3/20 is our answer there. We can rent calculators, so if you want a graphing calculator for Thursday or the test on Tuesday, you can just rent it downstairs in our Math Student Success Center, and you can just check it out for during the class. All right, 1.17 to 9.9 days, 1.17 days to 9.9 days. Again, since the units match, they cancel out as well. And we're going to move this over 2 spots. That means we got to move this over 2 spots. So this is really 117 over 990. Okay? If you were doing it by hand, you could break it down. 117 is divisible by 3 and all that stuff. Actually, 117 and 990 are both divisible by 9. So again, if you had your graphing calculator, you put that in your calculator and hit MathFrac, you'll get 13/110. So I'll put divide by 9 there so you guys kind of know where we got that answer. Okay? Both of them are divisible by 9, so the 9's would cancel out. 3 1/4 hour to 6 hours. How do we do that? We have to change it to a improper fraction. So do you remember how to do that? 4 times 3 is 12. 12 plus 1 is 13. So this is 13/4 over 6. Okay? In your calculator, you can actually do this, and I'll show that real quick to you, those that have your calculator. I'm trying to do it where the glare's not really there. So we can do parentheses 13/4 like that. So there's our fraction up top, and parentheses, a parentheses above the 8 and 9, divided by, what is it, 6? And if you hit math frac, you'll get 13/24. Those that are doing it by hand, this just is bringing back memories of chapter 4. So this is 13/4 divided by 6. Do we ever divide by it? We multiply by the reciprocal, okay? So if you're doing it by hand, we could write this as 13/4 times 1/6. And notice 13 is not going to cancel out with any factors or 4 or 6, so you multiply straight across the top to get 13, straight across the bottom to get 24. So no matter how you do it, guys, you'll get that correct answer. Okay, but since we're allowed to use our calculator, all I expect you to show me is the initial setup of the ratio and the final answer. Okay? What'd you say?
I figured it out on mine.
Yes, if you have a scientific calculator, you have a fraction button there. It's only those that don't have a calculator at all that have cell phones today where the fractions and stuff really won't work out. All right, G, guys, what we're going to do is turn both of them into improper fractions. So what is 7 1/5 going to change to? 36 over 5. Is everyone okay with that? 5 times 7 is 35. 35 plus 1. So that's 36 over 5. All over, what's 7 1/3 going to change to? 22 over 3. And again, if you're doing it by hand, this would just be 36/5 times the flip, 3 over 22. And again, you could break 36 down to 4 times 9 or 2 times 2 times 3 times 3, all that stuff. But it's a lot easier just to do it in our calculator. So we have 36/5 in parentheses divided by 22/3 in parentheses like that. And all I have to do is hit math and fraction, and it reduces it to 54 over 55, which is a lot nicer than having to do that stuff by hand. Okay. All right, so now they're just showing you guys that we want to make sure we're paying attention to the same unit, so we're not going to worry about feet and to inches and quarts to gallons. Nickels to dollars aren't bad because we can do that. Minutes to hours aren't bad because we can do that and so forth. But let's go ahead and look at A. Let me pull this so we can see the whole thing. There you go. 81 miles to 42 miles. It's going to be exactly like what we did above. 81 miles to 42 miles. The miles are going to cancel out because they do have that same unit. And then how does 81/42 end up breaking down? (27 over 14). Is that okay? Let's not worry about quarts to gallons or feet to inches quite yet. That's something that we're going to see in Chapter 8, the unit conversion between quarts and gallons and all that stuff. Let's jump to nickels and dollars, okay? In order to come up with a ratio, you have to have the same unit, okay? So 5 nickels to $4, how many, which way can we go? Well, we can't really, if we have 5 nickels, do we have $1? No. But if we have $4, do we have a bunch of nickels? Yes, okay? So what we're going to do is we're going to leave nickels alone. So we're going to have 5 nickels, but we're going to figure out if we have $4, how many nickels is that? How many nickels are in $1? Does anybody know? There's 10 dimes in $1. 20, right? How do we do that? You say $1 is 100, right? And divide by a nickel, which is 5 cents. You have 20 in there. So if we have $4, we'll just take this times 20 nickels, right? And how many total nickels would we have if we had $4? We'd have 80 nickels, okay? So really when we go to do our ratio, we're going to use 5 nickels to 80 nickels as our ratio, okay? So 5 nickels to 80 nickels is our ratio. And again, if you're doing it by hand, you could break 80 down because 5 goes into it, so 5 would work. Or in your calculator, if you hit 5 over 80 and hit math frac, that's just 1/16. If you have 5 nickels, what do you have? You have 25 cents, okay? Or $0.25. But $1 would be $0.25 of 4. So 1/16 is where that's all happening. All right, minutes and hours, same idea. If we have 50 minutes, do we have an hour yet? No. So we're going to change hours to minutes. So again, those units are the same. How many minutes are in an hour? 60. So we're going to time the 5 hours by 60 minutes. So if we have 5 hours, how many total minutes do we have? 300. And again, remember, you can use your cell phone or your calculator right now. So we have 300 minutes total. So when we go to do our ratio, guys, we're going to use 50 minutes to 300 minutes. And remember, whatever's stated first is just always your numerator. So we have 50 minutes over 300 minutes. Minutes would cross out, and again, 50 over 300, you could break it down 2 times 5 times 5 and all that stuff, or you can put it in your calculator and hit math frac, you'll get 1/6. So 50 minutes is 1/6 of 5 hours. And that's something too, I don't know, you guys aren't probably like me, I've always been weird, but like if I'm on a trip, I would always do that kind of thing. Like if I have a 5-hour trip and we've gone 50 minutes, I kind of try to think the ratio. Like I do it today with our weeks. You have a 16-week semester, we're 10/16 done, that kind of idea. I'm doing ratios when I do that, all right? Last one, if you have centimeters, do you have a meter? No, there's 100 centimeters in 1 meter. So what we're going to do is we're going to change the 7 meters to 100 centimeters. So if we have 7 meters, guys, we have 700 centimeters. Centi, like century. How many years are in a century? 100. So how many centimeters are in 1 meter? 100. So really our ratio that we're going to deal with is 60 centimeters compared to 700 centimeters. Again, our units are going to cancel out. 60 over 700, we're going to be able to reduce. If you hit math frac, you should get 3 over 35. Does that look right? Is anybody following along on their calculator and getting those? Are you getting, okay. All right, so the key thing is when you're doing these ratio, guys, is to make sure you have the same unit, okay? So make sure you have the same unit. So always change the larger unit to multiple of the smaller, right? So dollars was our larger unit, so we changed it to multiple nickels. Hours was our larger, so we changed it to multiple minutes. And meters was our larger, so we changed it to multiple centimeters, okay? Always kind of go backwards to that smaller unit there. All right, so on the back, this is one of my favorite skills, is proportions. How many of you guys have seen proportions before where you cross multiply? Does that sound familiar at all? A proportion is when one fraction is equal to the other, and it's what I've been saying the whole time with cookie cake, is what, if I'm supposed to get 2/5 of the cookie cake, and the cookie cake's cut into 30 slices, I shouldn't just get 2 slices, I should get more than that, okay? So when we come to solving proportions, we want to just keep that ratio the same, all right? So how we do this is we cross multiply, and it doesn't matter who multiplies first or anything, okay, guys? So we have 2 times 3 and 5 times x. It doesn't matter which way we do it, okay? I typically like to keep my variable on the left-hand side, okay? So what is 5 times x? That is just 5x, all right? So we have 5x on 1 equals 2 times 30. Do you have to show it like that, 2 times 30? No, you can go right to 60. The only reason why I'm showing it like that is for those that are seeing proportions for the first time, you're going to be like, where the heck did 60 come from? Okay. So we have 5x equals 60. And then what's the last operation to get that x by itself, guys? What operation is this right now? Multiplication. How do you undo multiplication? Divide by 5. You got it. So we're going to divide this side by 5. When we divide that side by 5, 5 over cancels to 1, so we have x. But if we divide the left by 5, we have to make sure we divide the right by 5. And again, guys, we can use calculators. So 2 times 30, throw in your calculator, you get 60. 60 divided by 5, throw in your calculator, and you get 12. What does that mean? It means if our cookie cake originally started as 5 slices, and I was supposed to get 2 of those slices, if we chop it up to 30 slices, my 2 slices change to 12 slices, okay? I'm still keeping that proportion or that ratio the same. B, exact same idea, guys. We're going to cross multiply. Take one denominator times the opposite numerator and vice versa. Does it matter which one you do first? No, but I typically like to write my x first, okay? So again, we notice we have 5 times x, or 5x again. And what's our other side going to be? 7 times 4. All right? So we have 5x equals 7 times 4, which is 28. All right? Your last move is always going to be to get that x isolated by itself. What's the opposite of multiplying? Dividing. So over here, I'll cancel out and you'll get x. Over here, in your calculator, pending what MyMathLab wants, if they want a reduced fraction, you do 28 divided by 5 and hit math frac and realize 28 divided by 5 is a reduced fraction. So they would accept that. Or if they say, give me an answer rounded to so many decimal points, that means just take 28 and divide by 5. And you get 5.6, okay? So pay attention to what MyMathLab is asking for. If they want you to keep it as a fraction, keep it as a fraction, but make sure it's reduced, okay? So like if that was 28 divided by 6, you'd want to reduce it because they're both divisible by 2. All right. See, guys, they're trying to make it look scary by putting that 3 in front, but that's okay. We can still take 6 times 3x and 5 times 4, okay? We're going to take 6 times 3x and 5 times 4. So you take one denominator times the opposite numerator. This, guys, you just multiply the numbers, okay? What's 6 times 3? 18. So that will just be 18x. And then what's 5 times 4? 20. You got it. And then your last move is always going to be to divide that x by whatever that coefficient is in front. So we're going to divide both sides by 18. This will cancel out and you get x. Over here, this is what I'm talking about, guys. 20 over 18 is not reduced, so MyMathLab wouldn't take it. So in our calculator, what we can do is we can do 20 divided by 18, math frac, and get 10/9, because they're both divisible by 2, or put it in your calculator, what's 10 divided by 9, oops, you can't see it, 1.1 repeating. So let's just put 1.1 with the bar over it. But pending what they want you to round to, you'd write 1.1 or 1.11, whatever it may be, okay? And again, MyMathLab will just switch it up on you. All right, last one, guys. Again, they're trying to make it scary by putting multiple x's, but we can handle it, okay? We're going to take 5 times all of that. So we're going to do 5 times all of that. So we'll make sure we put parentheses to show it's going to be multiplied by all of it. And then we have 4 times x, or 4x. Now, I know you guys aren't 100% comfortable, but some of you are more comfortable with the algebra than you are the pre-algebra. How do we get rid of those parentheses? What do we have to do?
Multiply 5 times negative 2.
We're going to multiply the 5 by both of them, right? It's called the distributive property. So we're going to take this 5 in and multiply him by the x, but we're also going to take him and multiply him by the negative 2, okay? What is 5 times x? 5x. What is 5 times a negative 2? Negative 10, and 4x hung along the whole time. All right, so this brings us back to equations, which we don't want to forget, right? We want to make sure we feel comfortable with it. So the whole idea of equations is you want to get all the x's together on one side and anything that doesn't have an x on the other side, okay? So I'm going to focus on my x's first. I like to keep my x's positive. Do I have to? No. So let's move this 5x over to there, okay? So then they'll be on the same side. Since he's positive right now, what's the opposite of addition? Subtract. All right. What's going to happen here? What's 5x take away 5x? Nothing, right? We don't want that. That's good. So what's the only thing left on the left side? Negative 10. What is 4 take away 5? What happens to us? Negative 1x. All right? And I wrote it purposely like that because I want you to realize that we still don't have x isolated, do we? Who's in our way right now? The negative 1, and that's multiplication. So how do you undo multiplication? Divide by negative 1, right? So what's a negative divided by a negative? And what's 10 divided by 1? 10. And what's a negative divided? Hey, he just cancels out and we have x. And that's what's great, guys. I know you don't realize what we're doing, but we're finding that unknown. If we put 10 up on this side, what's 10 minus 2? What's 10 minus 2, guys? 8. 8 over 10 reduces to 4 over 5. We found the unknown. Could you look at that and know that right off the bat? No. But we were algebraically able to work backwards and solve it. All right, the last one is why, now that we know how to set up proportions to use it to solve for unknowns, we can use it in everyday life. So I use proportions a lot when I'm like such a penny pitcher when it comes to shopping. So I use proportions all the time with unit pricing. Anymore they have like the unit price on the tag. But before that, I would say, okay, this one has 5 in it for $4, but this one has 3 for $2.50. Which one's the better deal? And you could use proportions, okay? So on this one, it says an architect's blueprint, 1 inch corresponds to 5 feet. So guys, right here, I set up my first proportion. 1 inch equals 5 feet. So for every 1 inch, that blueprint is representing 5 foot, okay? So then what we're going to do is we're going to set up an equivalent ratio over here, and we have to make sure the units match. And we'll have to make sure inches are on top here and feet are on top here, pending what they give us, okay? So it says, find the length of a wall represented by a line that's 3 3/4 inches. What am I going to have to do with 3 3/4? Change it to an improper fraction. You got it. So what's 4 times 3? 12. What's 12 plus 3? 15. 15/4 inches. So is he going to go on top or bottom? Top, because inches were on top over here. So this is 15/4 inches. So how long would the wall be in feet? We don't know, so that is our x. You got it. So you're going to always be told an initial sentence to set that initial ratio, okay? That 1 inch to 5 foot, 1 tablespoon to 3 cups, whatever it may be if it's a recipe. So set that initial ratio up and then set that bar and whatever they give you. So they could have said, hey, how long is the blueprint if the wall is 12 feet? And you'd put X inches here and the 12 feet down there, okay? So now that we have our units kind of there just to match, we're not going to worry about them, okay? We're just going to focus on the numbers. We're going to take 1 times X and 5 times 15/4. So we have 1x equals 5 times 15/4. Do we really need that 1 in front of the x? No. So on this, guys, I'm just going to put in my calculator 5 times 15/4 like that and get my answer. That's 18.75 feet. So if he really had this blueprint and the certain wall was a little less than 4 inches long, in real life we know it's about 18, 19 feet long, okay? And that's the whole idea.